As of late, we got a gander at some dazzling pictures as Webb peers back. Around the beginning of everything, the James Webb Space Telescope, JWST, has uncovered a revelation that challenges the texture of our grasping. This new revelation has provoked the curiosity of stargazers and researchers and suggests a possibly huge occasion that may change the universe as far as we might be concerned. The finding is profound to the point that it raises worries about the premise of our astronomical presence. Might this revelation at some point lead to the finish of all we know? Is the universe near the very edge of an extraordinary occasion beyond our ongoing understanding? Join us as we investigate the most recent disclosure of the James Webb Telescope and how it could shape the universe. When we analyze the universe's edge, we start with the discernible universe. It's like seeing through a window into the region past the detectable universe. The detectable universe includes all that we can now recognize, measure, and analyze with our telescopes and space missions. It is an assortment of stars, worlds, and heavenly bodies that are noticeable to us. However, the recognizable universe is simply a piece of the entire universe, a little piece of a monstrous vast pie that people can study and see. Yet, the general size and type of the universe remain a secret. The width of the discernible universe is about 93 billion light-years. This figure is the aftereffect of different elements, including the distance that light can go in 1 Earth year, 9.46 trillion kilometers or 5.88 trillion miles. A light year is the distance traveled by light, the quickest thing in the universe, in 1 year. The assessed age of the universe since the Big Bang is 13.8 billion years. This means that light radiated by objects in space that people can see has been traveling toward Earth for close to 13.8 billion years. That suggests that the perceptible universe is 13.8 billion light-years in each direction from Earth and 27.6 billion light-years in diameter. However, Hubble's regulation expresses that space has been extending since the Big Bang, and thus the recognizable universe has been growing. Estimates of this development demonstrate that objects that emitted light 13.8 billion years ago from a distance of 13.8 billion light-years are now significantly farther away from Earth, around 46 billion light-years away. This shows that the perceptible universe extends more than 46 billion light-years in every direction from Earth and has a diameter of around 93 billion light-years. So, when we say the recognizable universe's breadth is 93 billion light-years, we're discussing an unfathomable range around 13.8 billion years ago in a very strong blast. This blast started what we presently allude to as the infinite expansion. Since that noteworthy moment, the universe hasn't merely been extending but has also been speeding up. Confounding powers like the strange dark energy appear to be driving the speed increase, pushing the universe's limits endlessly further apart. Matter began to shape under the draw of gravity as the universe extended. This gravitational attraction pushed particles together, resulting in the formation of astounding designs such as stars, worlds, and eventually planets like our own dear Earth. Given the universe's steady development, the recognizable universe expands by another light-year each Earth year. At the same time, light from farther objects continues to reach Earth for the first time. This means that we are seeing increasingly more of the universe as time elapses. While we will never be able to observe the entire universe from Earth, the field of observation is continually expanding. Advances in technology capture and analyze electromagnetic radiation beyond the visible range, allowing us to find and view distant individual worlds, clusters, and superclusters in the recognizable universe. Specific telescopes like radio telescopes, X-ray telescopes, ultraviolet telescopes, infrared telescopes, and others have been useful in this regard. The notable Hubble Space Telescope and James Webb Space Telescope have enabled the observation of the first stars and galaxies that emerged in the visible universe, making these wonders more accessible to the public. Regardless of its immensity, the universe is strangely empty. Even if we reduced our entire solar system to the size of a quarter, the closest star would still be about 2 soccer fields away. This vast emptiness extends only within our own Milky Way galaxy, which is one of billions in the observable universe, giving us a sense of the enormous size. You might be asking why we can't simply see everything in the universe. There are various explanations for this limitation. Despite the fact that light is the fastest object in the universe, it still takes time to travel through space. This means that when we look at distant objects, we are essentially looking back in time. The farther away an object is, the more its light has traveled to reach us. It's like looking through a vast time machine, unraveling the history of our universe as we witness galaxies millions, if not billions, of light years away. However, there is another factor at play. The universe is expanding. Consider the surface of an inflated balloon covered in spots. The spots move apart from each other as the balloon expands. The universe follows the same principle. Galaxies drift away as the fabric of space stretches. The light emitted by distant objects undergoes a change known as redshift. Due to this expansion, light wavelengths are stretched, with objects moving away shifting to longer frequencies, which are typically perceived as a reddish color. Some celestial bodies eventually pass beyond a critical distance known as the cosmic horizon, where their light is simply too far away to reach us due to the universe's expanding nature. Given these two central factors, the light's journey through time and the expansion of the cosmos, it's not surprising that we haven't seen the entire universe yet. Even with the most advanced telescopes and technology, our vision remains limited by the fundamental characteristics of the universe. Let's delve a bit more into these ideas. The universe's size is astounding. Researchers use measurements like light years to indicate the distance that light travels in a year, approximately 5.88 trillion miles or 9.46 trillion kilometers. Our universe, the Milky Way, is around 100,000 light-years across. Even within our galaxy, the nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. When we explore space, we can see galaxies billions of light-years away. This means that the light we see from those galaxies began its journey billions of years ago, giving us a glimpse into the universe's early history. The mystery of the universe's edge and the quest to understand the universe's possible edge or limits have drawn the attention of various people from different fields. While definitive answers continue to elude us, three major hypotheses have emerged, each providing a unique perspective on the vastness of space. The first hypothesis posits that the universe is infinite, with no apparent end. This idea aligns with the cosmological principle, which states that the universe is isotropic. Its consistency and appearance are the same from every vantage point. If this idea is true, it implies that the universe has no limits and can expand forever in all directions. The second hypothesis offers an alternative view, arguing that while the universe may be finite, it lacks a discernible edge. Instead, it is compared to a vast curved space similar to a globe. In this scenario, if one were to travel in any direction indefinitely, they would eventually return to their starting point, akin to circumnavigating the Earth. The third hypothesis, the multiverse theory, presents the intriguing idea that our universe is just one among many. Consider a vast number of universes, each with its own set of physical laws, constants, and characteristics. These universes may be completely different and operate independently of one another, or they may be interconnected through complex systems, forming a massive and intricate multiverse. Exploring these theories generates both scientific and philosophical interest. The concept of an infinite universe challenges our notions of space and our perception of its boundlessness. On the other hand, a finite universe without an edge challenges our ideas of limits and progression, suggesting the possibility of recurring patterns within the fabric of space. The multiverse theory, with its parallel universes, offers a rich terrain for exploration, proposing the existence of realms vastly different from our own. If true, it could imply that variations in physical laws and fundamental constants can lead to entirely different forms of existence, opening up a universe of possibilities beyond our current understanding. However, these ideas remain theoretical and elusive. Researching the universe's edge involves significant challenges. It is difficult to definitively prove or disprove these hypotheses due to the vastness of cosmic space and the limitations of our current observational tools and technology. The discovery of the universe's edge has been an intriguing journey rich in theories and reflections. Yet one groundbreaking tool, the James Webb Space Telescope, JWST, stands out as a beacon of hope, revealing insights into the mysteries that shroud the universe's origins. This remarkable instrument has the potential to uncover our universe's hidden history, allowing us to gain knowledge far beyond what was previously imagined. The JWST is a technical marvel, specifically designed to observe the universe with unparalleled precision. Its unique features enable us to peer into the origins of the universe. The JWST has discovered massive galaxies that date back between 500 million and 700 million years after the Big Bang. According to recent research published in Nature, these ancient galaxies challenge predictions with sizes significantly larger than expected for their age. These astonishing findings cast doubt on established theories about the formation and evolution of galaxies in the early universe. Astronomers initially expected to observe small, young galaxies during the telescope's observations. Instead, they were astonished to find these immense, vast entities, which have altered the narrative of cosmic development. The development of these ancient galaxies is profoundly surprising. Contrary to prevailing thought, these cosmic giants have reached a similar level of development as our 13-billion-year-old Milky Way. According to Dr. Lear, the principal investigator of the study, this finding challenges our understanding and opens the door to a new perspective on how galaxies formed in the early universe. Additionally, the JWST has recorded light from the universe's earliest stars, taking us back to when the universe was only 300,000 years old. These early stars, known as population 3 stars, have very distinct properties. They formed when the universe was primarily composed of primordial elements such as hydrogen and helium, with minimal traces of heavier elements. Unlike contemporary stars, population 3 stars lacked heavier elements, leading to a brighter and more intense light output. These ancient stars could provide crucial information about the formation of galaxies and the chemical evolution that followed. One of the most significant discoveries of the JWST is the observation of 13-billion-year-old galaxies whose shapes and structures are strikingly similar to our Milky Way. These galaxies serve as time capsules, preserving the universe's early stages. Their remarkable similarity to our own galaxy challenges previous assumptions about the early universe's chaotic and violent nature. According to Dr. Lear, the JWST observations have completely reimagined our understanding of the early universe. These revelations suggest that some galaxies achieved a high level of development and structure in a short period of time. Such findings not only cast doubt on existing models of galaxy formation, but also invite us to reconsider our views on the complexity and diversity of cosmic evolution. As we navigate the cosmic waters with the James Webb Space Telescope, each observation opens up new vistas of knowledge. This pioneering instrument continues to unveil the secrets of the universe's edge, allowing us to grasp our cosmic roots in unprecedented ways. The JWST has undeniably revolutionized space science, pushing the boundaries of human knowledge and expanding our grasp of the vast universe that stretches beyond our comprehension. The James Webb Space Telescope represents a monumental leap forward in our ability to probe the depths of existence. Its advanced capabilities, including its large primary mirror and suite of scientific instruments, enable observations that were previously beyond our technological reach. Located at the second Lagrange point, L2, approximately 1.5 million kilometers from Earth, the JWST operates in a region where it can maintain a stable orbit and avoid interference from Earth's heat and light. One of the JWST's key missions is to study the formation of stars and galaxies in the early universe by detecting infrared radiation, which can penetrate cosmic dust and reveal celestial objects obscured from visible light. The telescope can capture images of galaxies that formed shortly after the Big Bang. These observations provide valuable insights into the conditions and processes that led to the formation of the first galaxies and stars. The telescope's ability to analyze the light from distant objects also allows astronomers to study the chemical composition of galaxies across cosmic time. By examining the spectral signatures of elements present in these ancient galaxies, researchers can trace the evolution of chemical elements from primordial hydrogen and helium to the heavier elements forged in stellar interiors and dispersed through supernova explosions. Furthermore, the JWST plays a crucial role in studying planetary systems beyond our solar system, known as exoplanets. By utilizing its powerful instruments to analyze the atmospheres of exoplanets, the telescope contributes to our understanding of their potential habitability and the processes governing their formation and evolution. This research is essential for addressing the age-old question of whether life exists beyond Earth. In addition to its scientific achievements, the JWST represents a triumph of international collaboration and engineering ingenuity. Developed through a partnership between NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA, the telescope embodies the collective commitment of the global scientific community to advancing our understanding of the universe. The development of the JWST was not without challenges. Initially proposed in the 1990s as the successor to the Hubble Space Telescope, the JWST faced numerous technical and financial obstacles that delayed its launch by several years. However, the perseverance of scientists, engineers, and administrators ultimately paid off with the successful launch of the telescope in December 2021. Looking ahead, the JWST promises to continue transforming our comprehension of the universe. Its exceptional sensitivity and resolution will enable astronomers to study the faintest and most distant objects in the cosmos, shedding light on some of the most profound questions in astronomy. These include the nature of dark matter and dark energy, the formation and evolution of galaxies, and the origins of planetary systems. Additionally, JWST observations will contribute to our understanding of the fundamental physics that govern the universe by testing theories of gravity and cosmology in extreme conditions, such as near black holes or during galactic collisions. The telescope will provide critical data to refine our models of the universe's structure and composition. Beyond its scientific impact, the JWST serves as a source of inspiration and wonder for people around the world. Its stunning images and groundbreaking discoveries capture the imagination and curiosity of both young and old, fostering a deeper appreciation for the vastness and beauty of the universe. In conclusion, the James Webb Space Telescope represents a milestone in human exploration of the universe. With its unparalleled capabilities and potential for discovery, the telescope is poised to reveal new insights into the origins and evolution of galaxies, stars, and planetary systems. As it continues to operate and deliver groundbreaking science, the JWST will undoubtedly leave a lasting legacy as one of humanity's greatest achievements in space exploration.